Hi, and welcome back to Programming for Biologists. So today, we are going to be looking at Booleans. So Booleans allow us to sort of ask questions within our code and get back the answers true or false. And we can use these to test if different variables are equal to each other, or different values that we're pulling out of tables or strings. And we can use these comparisons to, do different things with our data. Maybe we want to filter out all of one condition from a data set. So if we find that that condition exists, then we can get rid of it or include it. We can use them for flow control. So we might want to process certain bits of our data in one way and certain bits of our data in other ways. But when it comes down to it, Booleans are basically true or false. So obviously we can just type in these variables if we wanted to, these Booleans, and assign them to variables. But this isn't a very typical use case. In most cases, we're going to be asking questions about our data and getting back these Booleans as true or false values. Now, the way that we make these comparisons are by using different operators. So the first operator that we're going to look at is this equals sign. And this basically checks if two values are equal to each other. Now, they don't have to be numbers. These could be strings as well. So, A is equal to A, for example. And you should note here that we can't just use a single equal sign, because that is what we're using up here to assign values to different variables, right? So a single equal sign in Python is an assignment operator for assigning values to variables, whereas equals is this Boolean operator, which is checking for whether two different things are equal to each other. Now, the second thing is not equals, and this checks if things are not equal to each other. So this is an exclamation mark followed by an equal sign. And then we have some basic mathematical operators, such as greater than, less than. And then by combining greater than and less than with equal signs, we can have greater than or equal to. So how do these work in practice? So if we run these sections of code, we can make basic comparisons. So we can test, is 1 equal to 1? And that gives us a value of true. And then we can test if 1 is equal to 3, which it isn't, and this obviously returns false. Similarly, with the not equals, we can say, is 1 not equal to 1? Well, 1 is equal to 1, so 1 is not equal to 1, so we've got this false returned, right? Similarly, if we use these mathematical operators, 5 is greater than 3, but 3 is not greater than 3. And then we can use our greater than or equals, and we can see, 3 is greater than or equal to 3 because 3 is equal to 3. And this returns true. So what Booleans are doing is basically allowing us to compare different values to each other. And these could be outputs from functions, or they could be simple mathematical things like we have here. Now we have other operators that we can use with Booleans, and these allow us to make multiple comparisons between different things that return Booleans. So there are 3 of these that you'll use most often, which are and, or, and not. So and basically allows you to check if two values are true. And it will only return true itself if both of those values are true. And then you have or, which basically says, is this true or is this true? And if either of those things are true, then it will return true. And then finally we have not. What not does is basically turn true into false and false into true if it's in front of them. So I'll have a look through these very quickly just to get a feel of how these work. So here, if I run this little block, we can see that true and true is true because both of these values are true. And here we can see that true and false is equal to false. And obviously false and false is false. So anytime we use and, it is only ever true if everything in the question that we're asking the code returns true. So obviously we don't just need to put in these true and false statements. We could use mathematical operators like we did before. So for here example, here we have 1 is equal to 1, which is true, and 5 is greater than 2, which is true. But on this next line, so this returned true, this first statement. On the second line here, we have 1 is equal to 1, which is true. And then we have and 5 is less than 2. And in this case, 5 is not less than 2. So this is a false statement. And so because we have a true and a false, we get false. Okay, so finally, we're going to have a quick look at or. Well, we'll have a look at not as well, but or is a slightly more complicated thing to get your brain around. And if you don't understand these straight away, you will get used to it as we look at them in the next lesson and how we can use them in combination with if statements to basically control the flow of our code. Okay, so or is basically saying, is this or this true? So for the first statement here, we can guess, so true or true is true, so this should return true. And then true or false, so true is true, so this should return true as well. And then false or false should return false. And if we run this, this is what we get, that either of these are true, which is true, and either of these are true, which is true, and is either of these false. And like I said before, not is quite simple when you think about it in terms of just one statement. So not true is false, right? Because it's not true. And not false is true and true. So both of those are true. So that returns true. And here we have false or not true. So this is an or statement. So only one of these needs to be true for it to print true. And not false is true. So that prints true. Now I realize I've said true and false a lot of times just now. But these are things that are important to get your head around. Because Booleans are really useful for controlling lots of things inside of Python. You know, lots of times when I'm reading through a data set, I might not want every single line of that data. Maybe I only want to pull out specific experiments in like one massive file. And in that case, I can ask whether the data on that particular line is from a certain experiment and only take that data, because I can set some condition that says, is this from this data set? And if it's true, then I'll keep that data, for example. So there are a few things to be aware of. So you can also express Booleans as values. So 1 is true and 0 is false. So if we say print 1 equals true, then this is true because in Python, 1 and true are basically equivalent when we're doing these Boolean comparisons. Similarly, 0 is false. So if we say 0 equals true, then this returns false. So this also means that we can kind of do mathematical operations with true and false. And maybe this is a better way of thinking about how and or work. So and basically is timesing things together. So if you had true and false, 1 times 0 is 0, right? So that returns 0. Whereas an OR gate is more like addition. So 1 plus 0 is 1, so that's true. So, but there aren't many like practical applications for this. The only time I really use this is for working out how many true statements I have in a list, because you can basically just use them as numbers, right? If you can add them together. So we can add true, true, and false. So we've got 1 plus 1 equal plus 0. So that should equal 2. And we can see that that is true. And if we had a long list of comparisons of different types of comparisons, then we could just basically, if we created this list, we could just sum together all of the things in this list using this sum function. And this would return 4 because there are 4 true things inside of this list. Because true is 1 and false is 0. There are another couple of operators that we might look at in a bit more detail. So these are in. So in basically tests whether some value is in some iterable. We could do this as a number in a list, but in this case, for these examples, I've used letters inside of strings. So, for example, is I in like? Yes, so this is true. Is B not in and? Well, there is no B in and, so we can negate the in, just as we can with true and false. So the order here would be, is B in and false? But then it's not false, so it's true, right? And then finally, we could say, is X in subscribe? And that's not true, so we don't have a not in there, so this just returns false. So the last operator that I'm going to tell you about, just in case you accidentally start thinking you might want to use this because it does something different in a different programming language, is the is. So is behaves in a very strange way. Is checking if two objects in Python are basically exactly the same. And you will get different results depending on what you're doing. So here, if I just assign A to 1 and B to 1, and then I print A is 1, I get true. But this is a bit misleading because you might think that these two variables are saving different things. But what Python is doing in the background is being very memory efficient and saying, well, these values are both 1, so I'm not going to store them twice. I'm just going to say A and B are both equal to 1. So they probably have the same ID. So for like in this case, if we convert A, we keep A the same, but then we convert B to a float, they're both 1. It's just that A is now 1 as an integer and B is 1 as a float. So in this is comparison, this returns false, even though mathematically they're the same. Whereas our mathematical operator of equals returns true because 1, whether it's an integer or a float, is the same value, right? So just to give you an example here of the whole Python memory thing is if we just use lists. So here, what I'm doing is I'm creating a list A, which is 1, 2, 3, and list B, which I'm making equal to A. And because I've done that, Python is just saying, well, A and B are the same, so we'll just give them the same ID off somewhere in memory. But then for C, I'm making a copy of A. I'm not just saying that they're equal to each other. So now if I print A is B, I get true because they're the same list somewhere in memory, even though they're different variables. And even though C is identical to A because it's just a copy of A, it's returning false because it's not the exactly same object. So I would just avoid using is for making any comparisons and just use the equal signs, because unless you fully understand what the object IDs are for all of these things in memory, it will just create problems for you. The only time it would ever be useful is if you're checking if two mutable objects are still linked together somehow in memory, but you're not going to need that. Okay, so that is the basics of Booleans. And in the next session, we will be going over if statements and hopefully build on our knowledge of Booleans a bit and how we can use them practically inside of code to make our code do what we want it to do. Okay, so thanks for listening. If you find these videos useful, then please like and subscribe. Otherwise, have a nice day.